Hello, AP Physics students. I wanted to go over this problem solving for statics because your next task will be to do a quiz. Some of them are going to look like your examples, so I hope you look through those. But this is the process they have in Giancoli. It's a process I would do also, but let's go step by step. Choose one object at a time for consideration. It might be a diving board, it might be a sign or a brace. Make a careful free body diagram. Now this object, instead of being a single point, is going to have length, right, to it, whether it's the length is at an angle or if it's horizontal or vertical. Okay, so show all the forces acting on the object, including gravity. And where does gravity present itself? Right, where does gravity present itself? Right? It acts at the center of mass. So if it's a rectangle, put it at the midpoint. And the points at which the forces act. If you aren't sure the direction of force, it's okay. Choose a direction. Now, when we choose a direction, we need to establish a frame of reference. And for us, when we do forces and they're in 2 dimensions, right, we'll do kind of like positive to the right and positive up and down. So hold to that frame of reference. If the force is downward, then it'll be negative. If it's to the left, it'll be negative. If it's to the right, it'll be positive based on your frame of reference. But the beauty of all of this is you get to choose, right? If you chose the wrong direction for the force, your eventual calculation will give you a result with a minus sign, okay? The next thing is choose a convenient coordinate system, right? Not only are we doing the net force, because when you do statics, keeping something stationary, we don't want it to shift up and down or left and right, so that's why our net forces are 0. But guess what I also don't want? I do not want, right? I do not want my object to rotate. So if you select a frame of reference, a convenient coordinate system, let me emphasize this, select your 0, 0, right? I usually try to select a 0, 0 where there are 2 forces going through it so I can eliminate unknowns and values, okay? So be strategic, right? Be strategic with your 0, 0. Maybe that's right there, so pick that along wherever you want, okay? So the last thing, so we've got frame of reference up is positive, right is positive, however you want it, honestly. But the last thing is torque, and torque is about rotation, right? Rotation at an axis, right? Or about an axis or a rotation point. You need to decide which way is positive. Is that force going to cause it to go clockwise, right? Or is the force going to cause it to go counterclockwise? You get to decide whether clockwise is positive or clockwise is negative, meaning right, which way is it going to cause this object to rotate about that 0, 0 point, right? You're establishing this 0, 0. Is it going to cause the object to rotate in the positive manner or in a negative manner? The reality is, at no point along this object should the object rotate. So you can select, again, that 0, 0 at any point. The net torque should still be 0, okay? You should have an equation, right? You should have an equation in the x direction, in the y direction, and in rotation. So guess what? You could have up to 3 unknowns. Okay, you could have up to 3 unknowns. You've got 3 equations, so you should be able to solve for all the forces. I hope that helps give you a verbal overview of these problem-solving techniques. And again, you're going to do a quiz to see how you do, right? Multiple choice, it's fine. And then in the end, you're going to give me an idea of your confidence, right? Or any questions you might have, all right? Good luck. And we'll definitely cover it. We just want you to do a lot of legwork ahead of time, and we want to go through questions when you get back from winter break. All right, bye.